Hi guys, in this lecture I am going to draw dy11 connection. So here capital D is representing delta and here small y is representing star and here 11 is representing 11 o'clock position. 11 o'clock position. Here delta is represented in capital. So this is HV side, this is SV side, our primary side, and small y is represented in star which is LV side. Okay, and this representing either clock position or degree, which is phase displacement, phase displacement displacement phase displacement between HV and LV line voltage. HV and LV line voltage, and we can understand with the help of clock method. So I am taking a clock. Okay, so this is the clock, and we know that this is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we already know that the HV side, which is represented by uh, minute hand, and LV side, which is represented by hour hand clock. And we know that this minute hand is fixed at 12 o'clock position. 12 o'clock position are 0 degree or 0 degree position. Okay, and this hour and clock is rotating depending upon type of connection. So it is dy11 connection. So here this HV side delta will place at 12 o'clock position. Okay, this is HV side, and LV side is placed at 11 o'clock position. 11 o'clock position. So this is our end and this is minute hand. So this is HV side, HV side line voltage, HV side line voltage which is in delta, and this is LV side, LV side line voltage which is in star, and it is leading the HV side line voltage by 30 degree. So it is also known as a 30 degree lead connection. 30 degree lead connection. So from this it is clear that this is dy11 connection. So now we will draw dy11 connection. So let us start dy11 connection. So drawing dy11 connection. Okay, so here there is a this is delta, so we can draw delta in two ways. Okay, there is two possibility, but keep in mind that the phase sequence of the both side, HV side and LV side, should be what should be ABC, but HV side can be drawn in a two ways. HV side can be drawn in a two ways. So this is two possibility to draw HV side delta. Okay, but keep in mind that the phase sequence should be ABC. So I am taking this is A2, A1, or another way is I am taking this is A2 and this is A1. Okay, now this is taking B2, B1, and this will be C2, C1. Okay, so here if I take the terminal from A2, B2, C2, if I take the terminal from A2, B2, C2, so this will called A phase, and this will called B phase, and this is called C phase. So this is A phase, B phase, C phase. This is the one way to draw the delta. So here it is clear that the phase sequence is ABC, and we know that we always place the dot at A2, B2, and C2 terminal. Similarly, here we can draw another way delta. So if I take B2 here and B1 is here, and if I take C2 is here and C1 is here, and if I take the terminal from A2, B2 and C2, A2, B2, C2, so it is called A phase, and this will call B phase, and this is called C phase. Okay, so here it is also clear that the phase sequence is still same, A, B and C. So there are two ways to draw delta. So from this it is clear that we can draw dy11 connection in two ways. So by one, first I'm taking this connection. to draw dy11 connection. In case 2, I will take this to draw dy11 connection. So one by one we will draw. So let us take case 1 to draw dy11 connection. So case 1. So first of all, draw HV side delta. Okay, HV side delta. Okay, so I am drawing this. But keep in mind that the phase sequence of the HV and LV side should be same, that is A, B, C. So in first case, I am taking that this is A2, A1, and this is B2, and this is B1, and this is C2, and this is C1. And we know that dot is placed at A2, B2, and C2 terminal, and we always take the supply from A2, A2, B2, A2, B2, and C2 terminal. So this will call A phase of the supply, and this will call B phase of the supply, and this is C phase of the supply. Okay, so we can draw the star equivalent of this HV side delta. So this is A phase of the star equivalent, and this is B phase of the this delta of star equivalent, and this is the C phase. And I'm considering this is the virtual neutral. So this is the star equivalent of this HV side delta. So in order to draw dy11 connection, so in order to draw the LV side star, we will take a reference this HV side star equivalent. So I am this HV side star equivalent. So with the help of dotted line, I'm drawing here a line, and this HV side star equivalent I'm drawing with dotted line. This is HV side of the A phase, and this is HV side B phase star equivalent, and this HV side C phase star equivalent. Okay, so this is the A phase of HV side B and C phase. Okay, so as per the D by 11 connection by clock method, it is tilted by 30 degree, leading of the LV side star. Okay, so here LV side star is tilted 30 degree, only 30 degree from this. Okay, so this is A phase, and this is tilt at B phase, and this is C phase. Okay, but how identify that this is A phase, B phase, C phase? It will depend upon the type of connection at the HV side of the coil A2, A1, B2, B1, and C2, C1. So here it is clear that this is the A2, A1. So A2, A1 will be this phase. So this will be A2, A1. This will be A2, A1, and this coil is coupled to this phase. So this will be what? B2, B1. So this will be B2, B1. So this is B1, and this is B2, and this will be what? This coil is coupled to this phase. So this will be C2, C1. This will be C2, C1. This is C2 and C1. So dot will be, since dot is placed at A2, B2, C2, so here also dot will be placed at A2, B2, C2 terminal. So here we will take the output from A2, B2, and C2 terminal. So this is the output of A phase, B phase, and this is the output of C phase. And uh, load is what? So this is the load side or output side. We consider this is the load side or output side, and this is the supply side. This is the supply side. So this is the supply side. This is the supply side, which can be star or delta. In most cases, this is the star connection. So this is supply side, and this is the load side. So load will we also can be star or delta. Okay, now I'm considering that this the line current from the supply is IA, IB, this is IC, and this is IB. Okay, and since supply is supplying the power, so this winding of the HV side, the winding will absorb the power. So in order to absorb the power, the current will be flow from plus to minus. So we know that the dot is representing positive terminal, and undotted terminal is the negative terminal. So current will be flow from dot to undotted terminal, dot to undotted terminal. Similarly, this is the load. So we know that load can be star or delta, can be star or delta. So it is always absorb the power. So current will be flow from positive to negative. So the line current will be flow like this. So I am considering that this is IAL, this is IBL, and this is ICL. Okay, so since load is absorbing the power, that means the LV side of the star is supplying the power, and we know that the this dot is representing positive terminal. So this is positive, this is negative, and this is positive, and this is negative. Since the star equivalent is supplying the power, so current will be flow from minus to plus. Current will flow from minus to plus. So I'm considering that this is IPH1 on the HV side and this is IPH2 of the LV side. Okay, so this is the DY11 connection of the one way. And in order to confirm that whether this connection is correct or not, we will take the help of phasor diagram. So we know that in order to identify that whether this connection are true or not, we will first of all find out the line voltage. I'm finding out line voltage VAB. Okay, so here this point is representing A terminal, and from this point is representing B terminal. So this is the VAB line voltage. VAB line voltage. So this is connected to A2 and B is connected to A1. So VAB is equal to what? VA2 A1. From this is representing A phase and this is representing B terminal. So this is line voltage of LV side VAB, and this VAB will be VAN minus VBN. We can write it, and from this is VAN. Okay, so VA1, from this it is clear that VAN is equal to VA2 VA1. So this is VA2 VA1. Similarly, this VBN is representing VB2 minus VB2 V1. So this is minus VB2 V1, or we can write it VA2 A1 plus minus of VB2 V1. Okay, so with the help of these two equations, we can draw phasor diagram and confirm that whether this connection is true for D by 11 connection or not. So let us draw phasor diagram. So first of all, I'm drawing HV side phasor diagram. First of all, I am drawing HV side phasor diagram. So this is VA2 A1 of the HV side, and this is VB2 B1 of the HV side, and this is VC2 C1 of the HV side. So this is VA2 A1 of the HV side, this is VB2 B1 of the HV side, and this is the VC2 C1 of the HV side. Okay, and similarly we know that the coil voltage of the parallel to each other, the coupled coil of the each phases are parallel to each other. So so at LV side, LV side VA2A1 will be in phase with HV side A2A1. Similarly, LV side B2B will in phase with HV side B2B1, and LV side C2C1 will be in phase with HV side C2C1. So this is VA2A1 of the LV side, this is VB2B1 of the LV side, and this is the VC2C1 of the LV side. Okay, now we have to find out the line voltage of the HV side. So from this diagram it is clear that this VAB is equal to the VA2A1. So this is VA2N equal to VAB. So this is the HV side which is in delta. This is HV side line voltage which is in delta. HV side line voltage which is in delta. Now we have to find out the VAB. So here VAB is VA2A1 plus minus of minus VB2B1. So first of all, here VA2A1 is already known, but we have to find out the minus VB2B1. So this is plus VB2B1. So minus VB2B1 will be 180 degree out of phase. So we will draw minus VB2B1, which is 180 degree out of phase. So this is minus VB2B1. This is minus VB2B1. This is minus VB2B1, which is 180 degree out of phase. So if I add this VA2A1 in this, so we will get VAB. So I am adding this VA2A1. I am adding this VA2A1. So this is VA2A1. This is parallel to this. So this is VA2A1. So I am representing, this is VAB of the, this representing VAB of the LV side line voltage. So this represent LV side of the line voltage. Okay, this is a small VAB which is representing LV side line voltage. So this is a small VAB LV side line voltage which is in star, and it is lead by 30 degree. It is lead by 30 degrees. So this HV side, which is line voltage VAB, lags behind the LV side line voltage by 30 degree, or we can say that the LV side star leads the HV side uh, HV side line voltage by 30 degree. And if I place the clock here, so this will be 11 position and this is 12 o'clock position. So it will be DY11 connection. So it will be DY11 connection. Here you can understand that. You can understand that. This is 12 o'clock position and this is 11 o'clock position. And this is VAB and this is VAB and this is minus VAB and this is delta and this is in star and it is 30 degree leading. So this will be DY11 connection. So this will be DY11 connection. Now we can I am already said that there is also a one possibility that if I take this connection as a delta, then how to draw DY11 connection. So let us take case 2 to draw DY11 connection. So case 2 to draw DY11 connection, case 2, case 2. So uh, this is the case 2. So I'm drawing delta of the HV side of the delta. Okay. So I'm considering this is A2 A1 and this is B2 B1 and this is C2 C1. And we know that we always take the terminal from A2 B2 C2. So this is A2. I'm taking supply from A to A phase. So this will be A phase and taken from the B2. So this will be B phase and supply is taken from C2. So this will be C phase. And we always place the dot at A2 B2 C2 terminal, A2 B2 C2 terminal. So since supply is taken from A terminal, so this will be A phase and supply is taken from B terminal, so this will be B phase and supply is taken from C terminal, so this will be C phase. So with the help of this star equivalent, we can draw the LV side um, star. Okay, so first of all, I draw a line from this and here I am drawing HV side star equivalent, HV side star equivalent, HV side star equivalent. So this is A, B, C, and since it is DY11 connection, so LV side is tilted by lead by 30 degree. So this is A, this is respective phases ABC. Okay, so but here we observe that this A to A1 not coupled to this phase as per our convention. uh, this should be A phase, this should be B phase and this should be C phase, but here we observe that this A to A1 will be here because this is coupled to this coil. That means this will be A to A1, this will be A to A1, this will be A to A1. Okay, and this C to C1 is coupled with this phase. Okay, so this will be C to C1, this will be C to C1 and this is coupled to this B to B1 will couple to this phase. Okay, so this will be uh what B2 B1 and dot is placed at on HB side, dot is placed at A2 B2 C2 terminal. Similarly, so dot is here at A2 B2 C2 terminal. Okay, now here we observe that this is B1. Here if I connect this B1 is connected to output and this C1 is connected to output and this A1 is connected to output. So this is B1 is representing B phase, C1 is representing C phase and A1 is representing A phase. But what is the problem here is here the A2 B2 C2 is sorted at neutral point N and output is taken from A1 B1 C1 terminal. But on the supply side we have taken output from A2 B2 C2 terminal. So comparison is not possible because here output is taken from the A2 B2 C2 terminal and here output is taken from A1 B1 C1 terminal. So in order to make the comparison possible, we have to take the output from the A1 B1 C1 terminal because here we cannot not take the output from A2 B2 C2 terminal. So in order to make a comparison, so we have to take output from on the HV side. We have to take output from A1 B1 C1 terminal. So we will take output from A1 B1 and C1 terminal. So if I take the output from B1 terminal, so it will be B phase and it will be A phase, and it will be what? C1. So it will be C phase. Okay, it will be C phase. So this is A phase, this is B phase, and this is C phase. Okay, now the comparison is possible because your output is taken from A1, B1, and C1 terminal. Okay, okay. Uh, now with the in order to confirm that whether this connection is correct or not, we will take help of the phasor diagram. So in order to draw, we have to find out the in order to draw the phasor diagram, it is confirmed. First of all, we have to find out the line voltage. So I'm finding out line voltage VAB. So this is A terminal and this is B terminal. Okay, so this is representing VAB voltage, VAB line voltage. So from this, A is connected to A1 and B is connected to A2. So here VAB is equal to VA1 A2. So here VAB is equal to VA1 A2. Similarly, here we can find out line voltage VAB. Line voltage VAB. So from this is VAB, we can write VAN minus VBN, and here VAN is VA1 A2, VAN is VA1 A2, and VBN is minus VB1 B2, minus VB1 B2, or we can write VA1 A2 plus this minus VB1 B2, we can write, or this will be, can write VA1 A2 plus VB2 B1. Okay, now draw the phasor diagram. So I am firstly I am drawing phasor diagram on the HV side. HV side. So uh, white color HV side phasor diagram. Okay, so this is VA2 A1, this is VA2 1 of the HV side, this is VB2 B1 of the HV side, and this is VC2 C1 of the HV side. So this is VA2 A1, this is VB2 B1, and this is VC2 C1 of the HV side. Now we know that coil voltage are parallel to each other. So uh, LV side line voltage, LV side coil voltage, this is VA2 A1 is in phase with HV side VA2 A1. Similarly, LV side VB2 B1 in phase with HV side VB2 B1, and LV side VC2 in phase with HV side VC2 C1. So this will be VA2 A1, and this will be VB2 B1, and this will be VC2 C1. From this diagram, VAB is VA2 A1 A2. So this is VA2 A1. So in order to find out VA1 A2, so we will VA1 A2 will be 180 degree out of phase of this VA2 A1. So uh, this will be minus VA2 A1. This will be minus VA2 A1. We can write VA1 8 minus VA2 A1. So we can write it VA2 A1, and this VA1 A2 is equal to what? VAB. VAB. Okay. So this line is representing HV side, which is in delta, line voltage. HV side line voltage, which is in delta. Now we have to find out LV side line voltage, which is equal to VA1 A2 plus VB2 B1. VB2 B1. So this is VA2 A1. So VA1 A2 will be 180 degree out of phase. So draw VA1 A2 180 degree out of phase. So this is VA1 A2. This is VA1 A2 180 degree out of phase. So this is minus VA2 A1, which is equal to VA1 A2. Okay, and this is VB2 A1. So if I add this VA1 A2 to VB2 A1, then we will get VAB. So I am adding this VA2 VA1 A2 in this. So this is VA1 A2 adding to this. Okay, so this is VA1 A2. So VA1 VB2 B1 plus VA1 A2 will be what? VAB of LV side. So this is VAB of LV side. So this will be VAB of LV side line voltage which in star. So this is 12 o'clock position which is in delta and HV side, and this is what 11 o'clock position, 11 o'clock position which is in star which is on LV side. So it will be what DY11 connection, or we can understand through a clock. So uh, so if I take the clock here, so this is 12, this is 12, so this is 11, and here VAB of the HV side line voltage, and this is VAB of LV side line voltage, and this VAB in delta, and this VAB in star. So this will be what DY11 connection. So in both way we can draw DY11 connection. So it is not necessary that we can take the output from the A to B to C to terminal. We can take the output from A1, B1, C1, or A2, B2, C2 C2 terminal, but keep in mind that the phase sequence of the HV side and LV side should not be changed. So this is the way how we can draw DY11 connection. So there are two ways we can draw DY11 connection.